Dear participants, now we are starting a new lecture, and this is lecture 19 of the subject on micro irrigation engineering. This lecture deals with water quality. Water quality is very important from irrigation point of view. If it is beyond the permissible limit, it spoils the soil, and it is hazardous to the crop growth, and sometime if the poor quality water is having heavy salts, heavy metals available in the water, this will be extracted by the plants and it may come to the food cycle. So, one has to be very careful while using poor quality water for irrigation purpose. Now, in this particular lecture, we will be covering topic on the parameters which are considered as suspended or dissolved materials in the irrigation water. What are the different indicators which can be used with respect to water quality, and then effect of water quality on micro irrigation system, mainly emitter clogging. When we say emitter clogging, means the opening from the drip emitter, the diameter of outlet of drip emitter is very small. And what happened when suspended particles are dissolved salts with the water, it causes the clogging of emitters. So, we will discuss in detail about emitter clogging, that is the main concern about us with respect to this subject. And then what are the different management practices that can be used while using poor quality irrigation water. Now, water quality, when we ask that what is water quality? So, water quality refers to the characteristics of a water supply that will influence its suitability for a specific use. So, for irrigation water, usual criteria include salinity, sodicity and ion toxicities. Now, what we see here when we look at the plant and when we are giving irrigation water, and this irrigation water contains salt, and when we are applying. So, what happened when the plant evapotranspiration takes place. So, transpiration from the plant as well as evaporation from this soil, when it takes place, what we find, the water, the salt available in the water, it gets remain in the soil, or when it is without vegetation, what happened, salts remain behind, and that causes the accumulation over a long time, and this soil becomes saline soil, or it becomes sodic soil, or some certain ions, certain salts which are available, this will remain in the soil, that will be harmful for the plant growth. So, when we talk of irrigation water quality, there are certain materials which are suspended in the water or it is dissolved with water. So, suspended material, it comes from the eroded soil particles, means when the water transport or the overland flow, it takes place from the land surface, and when the velocity of flow, overland flow, it increases. So, through runoff, it it comes and it erode the soil, and that will come to the stream, and when we are using this stream water for irrigation, so that will remain suspended. Or there are certain small size seeds, this could be also available in the water. Leaves flowing along with the stream, so plant leaves that also come. There are some certain other flowing material that becomes a debris, and then that is also not good from irrigation point of view, particularly when we are using micro irrigation, when we are using sprinkler irrigation. So, this may choke the system when we are using. So, suspended particles which are greater than 50 to 100 microns, such particles are possible that can be removed by using micro irrigation filters. And suspended particles which are less than 50 micron, that can be removed by flushing of filters regularly, time to time, flushing of lateral pipe, flushing of main pipe, sub main pipeline, or we have to use appropriate device, a brush, say it is a screen filter. So, the brush has to be used, nylon brush has to be used, or there are some other way. So, dredging is done to remove the particles which are between 50 to 100 micron. Now, dissolved particles, as the name says that it is dissolved. So, there are some total concentration of ion usually called salinity. So, there are some certain ions which are available in the water with some certain percentage, and these ions could be in the form of dissolved. So, these ions can be cation, it can be anion, or it could be in other forms. So, cations means these are, when we say cations, it means they are positively charged ions. They can be in the form of calcium, magnesium, sodium, or potassium. When we say anion, it could be in the form of bicarbonate, sulphate, or chloride. Other means other suspended material could be in the form of carbonates, nitrates, or some other trace elements of metals, that could be boron or some other heavy metals. So, as salinity increases, the crop yield also decreases, and this is a means this should be in a permissible limit. So, high concentration of exchangeable sodium can cause soil particle dispersion, and this what happened, this changes the soil structure, and also this reduces the movement of soil in the movement of water in the soil. So, that causes accumulation of salt, and that salt becomes like a sodic salt, and so specific management practices are needed to bring the soil again in a product to be productive. So, sodium, chlorides, boron, and other ions are toxic, and they are, if they are in high concentration, they become hazardous to the plant growth, or they hamper plant growth. There are different properties which deals with the water quality, and these properties could be say pH, electrical conductivity, total dissolved salt, the calcium, magnesium, sodium, potassium. So, these are the instruments which are used to monitor these parameters. So, say when we are talking about to know what is the pH of irrigation water. So, this can be used determined by using a digital pH meter. If one wants to know the EC, so one can use EC meter. For total dissolved salt, one has to filter the material, how much is the salt available, then one can use gravimetric method, means one has to dry the sample and get how much amount of the salt available in the water by using the gravimetric method. For calcium, magnesium, sodium, potassium, the these can be these parameters can be measured using flame photometer, and then there are specific wavelength ranges which are applicable, and that can be used to identify these elements. So, that means say the 54 nanometer of flame photometer is can be used for calcium. Similarly, for other elements one can see that these are the designated wavelength ranges which are used for knowing the these elements. Now, the other the properties could be chloride, sulphate, nitrate, and so this can also be used means the spectrophotometer is used with a specific wavelength to monitor chloride, say it is 515 nanometer, and then sulphate. So, a spectrophotometer of a specific wavelength of 450 nanometer is applicable for sulphate. Similarly, for nitrate. Copper, this can be found out by a spectrophotometer, that is atomic absorption spectrophotometer, and at the wavelength of 328. Similarly, for zinc, iron, and manganese, and these are the specific wavelength which can be by means wavelength meant for monitoring these ions with using the atomic absorption spectrophotometer. Now, one of the very important parameter indicator means one can know that, and salinity, alkalinity, sodicity, these are the some element, and depending on the concentration these salts can be determined. So, salts, so water quality indicator is expressed by taking the salinity as the one of the parameter. So, salts in soil or water reduces the yield. High water table or saline groundwater table, this high water table, this causes the upward movement of the salt at the soil surface, or because of the as such the rocks are such that where the water quality, groundwater quality itself is saline, and then because of the capillary movement of water. So, with this capillary movement of water, salt also get deposited on the soil surface, and so that is the another problem. Salts in the irrigation water, as such the source of water itself is having saline. So, this also increases the soil salinity. So, salt concentration in the root zone rise up to 2 to 5 times due to transpiration, because as long as the plant is there, vegetation is there, transpiration process will continue, and this what will happen when the plant will transpire the available soil moisture content in the soil, it will reduce, and then the salt concentration at the root zone will evaporate. So, by evaporation from the soil surface, this will cause increase in the salt concentration in the soil, and the ultimate effect is it comes for osmotic effect, means plant growth decreases to a decrease in the osmotic potential. So, movement of water it becomes it retards when the salt concentration in the water or in the soil is available. So, a specific ion effect, that is the concentration of a specific ions such as sodium, chloride, boron. So, when it is greater than the expected value from the osmotic effect alone, then this is the causing the movement of water, and these ions they affect the movement of water and then retard the growth of the plant. Now, salinity is when how much is the value of electrical conductivity of the water. So, based on the electrical conductivity, the soil salinity is measured. So, if means if we are means there are 4 classes it has been made, and the class 1, that is C1 class when we say. So, means C1 when the soil salinity is in the range of 0 to 0.25 decisiemens per meter, this is suitable for irrigation. C2 is the medium salinity, this is also there, means there could be moderate leaching can takes place, and then this water can be used for irrigation purpose. This high salinity means which is in the range of 0.75 to 2.25. So, by adapting suitable management practices to a certain extent, when there is a not means fresh water is not available, good quality water is not available, only this salinity means this water having this much of salinity, that is 0.75 to 2.25 is available. So, this water can be used with some certain allowing the growing the crop, which are should certainly certain tolerance, or we have to aid suitable management the salt to negate the effect of salinity that can be used. So, very high salinity if it crosses more than 5 decisiemens, and such water is not suitable for irrigation purpose. As per the United States salinity diagram classification, not only the electrical conductivity, but there is a sodium absorption ratio. These values are also available. So, combination of sodium absorption ratio and soil salinity, electrical conductivity, these two parameters when they are used. So, this can be such means this diagram it is suggested to use water for irrigation purpose. So, what we see here, this particular diagram in the x axis the electrical conductivity of water is available, and on y axis the sodium absorption is available. Now, when this this particular the other side of this they are plotted, and then one can see that whether this water is having high salinity or low salinity. So, this particular diagram is basically it is giving that when means electrical conductivity is given, this is a low, medium and high or very high. Just now I told you these values are available. So, as such from the electrical conductivity point of view, this is the scale, and when we go for the sodium absorption ratio. So, 0 to 10 it is given as low, then 10 to 18 this is a medium, and then 18 to 26 is high, and then greater than 26 is very high from the sodium absorption point of view. Now, each individual unit one can see this means this region when we say electrical conductivity of the water is low, however, the sodium absorption ratio is very high. So, accordingly this electrical medium, and then this and so when we come to this part means this is not at all suitable for irrigation. So, this is the way one can use. The other way the salinity it is also expressed by using the electrical conductivity of water and total dissolved salt. So, as such when we are using this particular chart, So, TDS and electrical conductivity of water, these two combination one can see that. So, if it is says TDS is less than 450 milligram per liter and the electrical conductivity of water is less than 0.7 decisimon per meter, means this is there is no as such difficulty for the taking using this much. So, there is no hazard from the means the effect of this water is it is not affecting much. This is a slight to moderate when the range of your PDS is 450 to 2000 and ECW is 0.7 to 3. So, degree of restriction for using this water means considering ECW and TDS accordingly one can select, and this is a severe case means when electrical conductivity of water is greater than 3 and then the TDS is greater than 2000, then it is a serious concern, serious concern, and one should restrict using this water. Now, the high concentration of sodium, I was telling about the salinity part. Now, sodicity is another part which is, so the sodicity is basically the how much amount of sodium salts are present in the water. So, which is expressed by sodium adsorption ratio. So, high concentration of sodium as such it is undesirable in water, because sodium absorbs on this means on the soil cation exchange sites and causing the soil aggregation to break down. So, what happened when this absorption take place, and so the sealing process it starts, and the soil become impermeable, and that causes that restrict the flow of water. So, sodium adsorption ratio is one of the parameter which is used for. So, just now I was telling about US salinity diagram, there sodium adsorption ratio was one parameter which was given. So, how the sodium adsorption ratio is computed? It is computed as sodium ion divided by the square root of magnesium plus calcium divided by 2. So, sodium adsorption ratio, that is Na and calcium plus Mg concentrations of the soluble ions in, it is expressed in milli equivalent per liter. So, sodicity, just a few minutes back in the diagram I explained you low sodium hazard, it is given between 0 to 10 sodium adsorption ratio, little or no hazard. S2, the medium sodium hazard, this is between 10 to 18 and this appreciable hazard, but that can be used with appropriate management. S3 is high sodium hazard, this is between 18 to 26. Like this, as the concentration of sodium increases with respect to calcium plus magnesium, the value it is means it is unsatisfactory for most of the crops, and it should not be that those soils become highly saline or highly sodic. Iron toxicity, these are the symptoms in the leaves. You can see when there is a high iron concentration of sodium, chlorine, boron, this affects the use of water for irrigation purpose. And what happened when sodium is available in high concentration in the water, when we are applying either through surface irrigation or through sprinkler irrigation system, means it will sprinkle on the leaf of the plant. So, besides this damaging the crop root system, it also damages the plant leaf. So, this such type of symptoms are there as when the sodium adsorption ratio it keeps on increasing. So, there is a permissible limit, and then permissible limit what we see for sodium is given here, it should be less than 3, for whether it is surface irrigation or it is a sprinkler irrigation system. Chloride, it is less than 4, it should means there is no effect, and then in this table you can see how with these different limits whether it has a moderate effect or it is a severe effect. So, this type of these data can become a guideline. Now, the most important thing from micro irrigation point of view, the effect of several dissolved as well as physical as well as biological or chemical compounds or elements available in the water, this becomes hazardous from the emitter clogging point of view. So, means one has to take care before installing the micro irrigation system, what is the specific type of the salts, what are the specific type of constituents available in the water, accordingly the means the measures can be suggested. So, what could be the causes of emitter clogging? One should learn that it could be physical or it can be chemical or biological. So, the other part is, for example, now here it is not just one parameter we are doing it and other we are not taking. So, they are so interdependent, they are they are interrelated. So, one should see that by reducing the microbial slime, tendency of suspended particles to stick or agglomerate and builds up in micro irrigation lines. Lines means here pipeline, it could be lateral line, it can be sub main line or so build up in the micro irrigation pipelines and emitters. So, are also reduced. In addition, small aquatic organisms such as snail eggs, larvae that are not really observed and analyzed, but they can develop into large colonies in the lateral tubing. So, this will result in combined physical and biological problem. So, one need to know fully that what kind of problems. So, physical factors, what are the physical factors? This could be the suspended inorganic particles such as sand, silt, clay, precipitates. It could be controlled by the. So, these physical items, this can be controlled by using proper filtration system. So, we will discuss about when we will come to the micro irrigation system and their filters, we will discuss in detail, but what are the basic elements which are causing the clogging. So, one is the physical thing, and then we need to apply appropriate measures. So, for physical clogging, one should use the chlorination treatment, and so that this can this will avoid the clogging due to physical clogging. Salinity means chemical effect is another parameter. So, salinity means there are some certain chemicals which are dissolved in as a cation. So, calcium, magnesium, manganese, iron and anions such as sulphate, phosphate, silicates, hydroxide, these are also present in the water, and that causes the clogging of emitters. So, one has to know about the elements and proper measures can be taken. Biological clogging is a serious problem in micro irrigation system, and so these elements can be sediment plus iron plus hydrogen sulphide. So, there could be these are the things, and that deposits in the tubing or lateral pipeline. So, on the inside the pipeline, the iron as well as hydrogen sulphide, they are causing the deposition, and then it reduces the flow as well as it accumulates on the emitter's outlet. So, physical, chemical and biological contributors to clogging, as I told you. So, physical could be the inorganic particles. So, here you can see inorganic particles, or it can be organic particles, non-aquatic. These are all which are listed here: sand, silt, clay, plastic, then aquatic organism, and then the snail, fish, insect larva, ant, spider. These are all physical suspended solids. Chemical could be calcium, means carbonates of calcium or magnesium, calcium sulphate, heavy metal, oil and other lubricant or fertilizers. They also cause the chemical precipitation when they react with the water, when they are applied. So, their reaction also causes the chemical precipitation, and that is prone to the prone to the clogging of micro irrigation emitters. Biological clogging, it could be due to filaments, slimes or microbial deposits. So, iron, ochre, then there is a sulfur, ochre, and then manganese. So, these are because of the microbial deposits. Water quality criteria, these are used for emitter clogging hazards. So, this which I told that what is the based on there the population, how much they are, this is the concentration it is available in the water. So, when it is given in this number minor, means they are not serious, rather we can say. So, when 50 milligram per liter suspended solid is available, we call it as a minor. When we say 50 to 100 milligram per liter, this is a moderate. Similarly, for other parameters it is there. So, they are to be checked, and then one should use carefully irrigation water after knowing these parameters, whether it is physical, chemical or biological. Similarly, the major constituents are the cation, anion, just now I told you. So, these are insoluble scale forming, and then anions, these are cation things, and then the anion is the carbonate, bicarbonate, phosphate, hydroxide, sulphate, and then anion precipitation compounds are in this form, they precipitate, and they are the major chemical constituents which are dissolved in the water that causes the emitter clogging. So, causes of the emitter clogging, there are some studies which has been taken by Gilbert and others. What they say that the results of representative 8 emitter systems from 4 water treatment, they did work for more than 4 years, and they analyzed that what is the chemical constituents. So, they have analyzed, and they found that the initial cause of the flow reduction was due to physical factor, followed by development of biological and chemical factor. So, the major factors involved were sand grains, which is mainly it is coming due to when we are taking water from the groundwater. So, if the pumping is at a very heavy rate, so at that time the sand it comes along with the water, or the river flowing water when it is used. So, this becomes a problem. So, one has to use proper treatment, and then this particular the results of the table that based on this interpretation was done by Gilbert et al. They carried out this research study in Arizona, USA. Management practices for using poor quality water. This is important that one has to use gypsum at appropriate quantity. So, knowing the particular concentration of a particular saline level, sodic level of the soil, accordingly gypsum has to be applied, and then the water is to be given up to certain depth, so that the leaching of salt it can take place from the soil. And then it is better to use localized irrigation like drip irrigation kind of a thing, instead of flooding this thing if the poor quality water is available. So, dripper has got tendency that it will be not the flowing water will not be the overland flow will not take place, it will be isolated at one particular place. So, and then it will form a bulb kind of a thing. So, this bulb outer side of the bulb will concentration of the salt will be more. So, to a certain extent poor quality water can be used by drip irrigation system. One is to use the means saline water tolerant crops, which can sustain when the quality of water is poor. One has means, and then the drainage is very important component. It should be coupled with irrigation system when we are using surface irrigation or even any other methods of irrigation. Drainage is important. Mulching is another technique where when the evaporation is taking place. So, salt which are precipitating over the soil and then evaporation takes place. So, these salts get deposited. So, in order to check the formation of the crust and on the top of the soil. So, mulching can be done. Crop rotation, following a particular rotation of the crop which are hazardous if to the soil. So, if we take the salt tolerant crop in a specific manner rotation we follow, so we to a certain extent slight poor quality water can be used for irrigation. So, here there is a list of crop. These crops are tolerant crop which can be taken in soil. So, and field crops cotton, safflower, sugar beet, barley, fruit crops such as date palm, guava, vegetable crops where we can see turnip and spinach. Semi tolerant, these are the list of the crop, means most of these crops are the vegetable crops. Of course, in the field crops sorghum, maize, sunflower, mustard, rice and wheat, these are semi tolerant crop to a certain extent, and then the say in Rajasthan conditions where there is a arid zone slightly or in some part of Uttar Pradesh also the semi tolerant crop where there is a salinity problem, people take Rajasthan, Haryana and Punjab. These crops are being taken up in a places where there is a slight salinity it exists, and then irrigation water is also saline. Sensitive crops are, these are the highly sensitive crop and this is being taken. So, sensitive crops, field crops are chickpea, linseed, beans, green gram, black gram, fruit crops, apple, orange, peach, strawberry, radish. So, what I see here that the crops which are suitable, which can be very much easily adopted, means drip irrigation can be adopted, mainly vegetable crops or fruit crops where means it can tolerate to a certain extent of soil salinity in the water, and this is very much the micro irrigation it can be adopted. Of course, from this table one can see that here the crops differ their tolerance limit with the poor quality water. So, growing salt tolerant crop using poor quality water can be taken considering the means certain reduction in the yield or minimizing the reduction in the yield if we take care of the quality of water, if we take care of the quality of soil, water the poor quality of soil. Now, let us summarize this lecture. So, I would say that yes, we discussed about water quality indicators, we discussed about the iron toxicity, we discussed about different factors which are prone, which are affecting the emitter clogging. So, there could be biological, there could be chemical, there could be physical. So, those parameters are to be taken into consideration while we are selecting a particular type of emission device, and then adopting a particular management practices using poor quality of water. Say in case of micro irrigation system, and when the quality of water it has got means that when it has got soil salinity, it has got total dissolved salts or sand or silt is available. So, it is better to use the high orifice sizes like micro sprinklers or bubbler can be used in that case when the physical components like sand or silt it is available in the water, and then emitters are getting clogged. So, one means this kind of the precaution one should take. Now, in forthcoming lecture we will be discussing about different types of numerical problem which we have dealt in the previous classes. So, that will be tutorial. Then these are the books and other reference material, internet references which are available. You may refer for more detail about this particular topic. So, thank you very much and good day.